So, Unit 3 is about polynomial functions, and we've talked about a specific type of polynomial function earlier, the quadratic. Now, the quadratic is a specific type of polynomial function. So, what is a polynomial function? Well, a polynomial function is a collection of terms that are added together. So what would that look like? What's an example of a polynomial? So a polynomial, we could have like 3x to the fourth minus 2x to the third plus x minus 7. Now that is a polynomial function, and each of these things are terms. So this is a 4-term polynomial function. Now, there's no set number of terms that a polynomial needs to have. Like a polynomial could just be y equals x. That is a very simple type of polynomial that had one term. Now, standard form of a polynomial is written when the exponents go from largest to smallest. So the exponents go from largest to smallest. So I'm going to give an example of that and a non-example. So an example of that would be like what I had up here, but I'll give a little bit of a different one. 5x to the sixth minus 4x to the third power plus x squared minus 1. Now notice that we don't have all the exponents from 6 to 1. Like there's no x to the fifth power, there's no x to the fourth power, and that's okay. Like this polynomial up here has x to the fourth, x cubed. There is no x squared, or x to the second power. That's okay. So this is an example of a polynomial in standard form because our exponents go from smallest to largest. We have 6, 3, 2, and no exponent. So a non-example could be something like 2x to the third minus 6x to the seventh plus 2. Notice that the exponents do not go in order from largest to smallest. I have 3 and then 7. 7 is bigger than 3, so that's why this is a non-example of standard form. This is still a polynomial, but it's not written in standard form because the exponents don't go from biggest to smallest. Now, the degree of a polynomial function is the largest exponent in a polynomial when written in standard form. So if we had the polynomial negative 14x to the 8th minus 7x to the 6th plus 5x to the 4th, well, the largest exponent is 8, so the degree of this polynomial function is 8 because it's the largest exponent when written in standard form. Now the leading coefficient is the number in front of the variable with the largest exponent. So if we had 4x to the 5th minus 3x squared plus 11, well, our largest exponent is 5, so the degree is 5, but the leading coefficient would be 4. We abbreviate leading coefficient as LC. The leading coefficient is 4. Okay. So we have the degree, which has to do with the exponents, and we have the leading coefficient, which is the number in front of the variable with the largest exponent. So then we're going to talk about how the leading coefficient and the degree affect the end behavior of a function. So we talked about end behavior of absolute value and quadratics, but now we're going to expand that to all types of functions. So if our degree is odd and the leading coefficient is positive, so an odd degree, the ends go in opposite directions. So if I have an odd degree and a positive leading coefficient, that means the left side is going to go down and the right side is going to go up. So as x approaches negative infinity, remember that means the left side, y approaches negative infinity, remember that means goes down. Now as x approaches positive infinity, y approaches positive infinity. An odd degree, the ends go in opposite directions. Look at one y goes down to negative infinity, one y goes up to positive infinity. So an example of a graph that would look like this could be something like this. And back in Unit 1, we saw something like that. Now, if I have an odd degree and a negative leading coefficient, the end behavior is going to switch. Remember, for end behavior, the x's are always the same. One x will go to negative infinity, and one x will go to positive infinity. So this part stays the same. Now the y part will change. The left side is going to go up, and the right side is going to go down if the leading coefficient is negative. Notice that there is still one side going up and one side going down in opposite directions. So an example of a graph that could look like that might just be a simple line. The left side is going up and the right side is going down. Now an even degree function, if the degree is even, the ends go in the same direction. When we had our absolute value functions and our quadratic functions, this is what we would have. So as x approaches negative infinity and as x approaches positive infinity, if we have a positive leading coefficient, both sides go up to positive infinity. An example of that would just be our quadratics that we graphed. We graphed a quadratic that looked like that, and both ends would either go up or both ends would go down. If the leading coefficient is positive, then both sides go up in an even degree function. Then if our leading coefficient was negative, let me use the same color, as x approaches negative infinity and as x approaches positive infinity, both ends go down. And we had quadratics that did that. But let's just draw. So this function, both ends are going down to negative infinity because it is an even degree and a negative leading coefficient. So we are going to be using this leading coefficient test a lot this unit, so you really need to have that memorized. So on the next page, we're first going to convert to standard form and then identify the degree, the leading coefficient, and the end behavior. So remember, standard form is when you have the biggest exponent first. Well, our biggest exponent is at x to the 5th power. So we need to put this in the front. So negative 4x to the 5th. Then our next biggest exponent is this x squared. So plus 3x squared. And then plus 10. So our exponents now go from biggest to smallest. Our degree is the biggest exponent, 5. And our leading coefficient is the number in front of that variable, which is negative 4. So our leading coefficient is negative, and our degree is 5, which is odd. 5 is an odd number. Remember, even numbers are numbers that you can divide by 2 with no remainder. So if this is an odd degree. So up here, an odd degree goes in opposite directions, and we have a negative leading coefficient, so this is our end behavior. As x approaches negative infinity, y approaches negative infinity, and as x approaches positive infinity, y approaches negative infinity. All right, now letter B, we cannot distribute this exponent. Don't do that. That's wrong. What we need to do is rewrite this as 2 times x minus 1 times x minus 1. And then we can FOIL this. So negative 2 times x squared minus x plus 1. Because I took each of these, I did x times x, which is x squared. Then I did x times negative 1, which is negative x. Negative 1 times x is negative x. And negative 1 times negative 1 is positive 1. So this is equal to 2 out in front still, negative 2 still out in front. Then we have x squared. We can combine these two to negative 2x plus 1. And then we can distribute the negative 2. So we have negative 2x squared plus 4x minus 2. And that's in standard form because our degree goes from biggest to smallest. We have x squared, x to the invisible 1 power, and no x. So our degree is 2. And our leading coefficient is the number in front, which is negative 2. So now our end behavior, we have an even degree and negative leading coefficient. Even degree, ends go in the same direction, and then negative leading coefficients right here. So our end behavior is this. Both ends are going to go down. So as x approaches negative infinity, y approaches negative infinity, and as x approaches positive infinity, y also approaches negative infinity. Both ends are going in the same direction. They're both going down. So what if we had something like this? Okay, we can't just look at the highest exponent because that's in factored form or intercept form. We're not going to spend the time multiplying this out. You won't need to for any reason. But what this equals to multiplied out is x cubed minus 12x squared plus 21x plus 98. Like if we were to multiply all that out, this is what it would equal. This right here is standard, this is standard form. This right here, that should look familiar when we graphed quadratics. That's intercept form or factored form. Or factored form. So intercept and factored form mean the same thing. All right, so here's our function in standard form, x cubed minus 12x squared plus 21x plus 98. Our biggest exponent is 3. And our leading coefficient, well, there's no number in front of x to the third, so there's an invisible 1 there. So leading coefficient is 1. So we have an odd degree and a positive leading coefficient. Odd degree, positive leading coefficient. So this would be our end behavior. The left side will go down as x approaches negative infinity, y approaches negative infinity, and as x approaches positive infinity, y approaches positive infinity. So notice the different forms. You may say, well, in intercept form, the biggest exponent I saw was a 2. But in standard form, my biggest exponent was a 3. That's different than up here. Look at the biggest exponent we saw here was a 2. And we also had a 2 for standard form, and that was our degree. So what was different? Well, what's different about this problem in intercept form, this part right here, and this right here is look at how many parentheses we have. There's only one parenthesis right here. We have 2 parentheses right here. If you don't have an exponent, there's an invisible 1 written there. So what we could do as a shortcut is 2 plus 1 is 3. So it's going to be pretty confusing, so you really need to pay attention and focus to determine how to figure out the degree. If you're in standard form right here, it is the biggest exponent. Like we did up here, biggest exponent was 5, the degree was 5. So in standard form, the degree of the function is the largest exponent. So an example would be something like 5x to the 7th minus 6x to the 4th plus x to the 3rd minus x plus 21. The degree is the largest exponent, which is 7. Our leading coefficient will be the number in front of that, which is 5. So in standard form, it is the largest exponent. In intercept form, we add all the exponents for each factor. So if we had something like x minus 3 to the 2nd power, x plus 6 to the 4th power, x plus 1 to the 3rd power. Now, yes, we could multiply all of that out, but that would get very confusing. In intercept form, we take the exponents and add them. So 2 plus 4 plus 3 is 9. So the degree is 9. And our leading coefficient is the number in front, well, there's an invisible 1 there. So you really have to understand, are you in intercept form or in standard form, because the method is completely different for finding the degree. So thanks for watching. Make sure to like the video and subscribe.